So we have come to the final part of the lecture about land cover change detection using remote sensing. And this is about the environmental conditions that should be kept constant between the two different points in time which we do our analysis of change detection. So when performing a change detection, we must try to keep as many environmental variables constant as possible. Otherwise, it might be that the change detection that we are doing is actually more related to other environmental variables than the land cover change that we actually want to detect. And we will then detect false areas that is actually not changing in reality. It's just a change in other environmental parameters. And these can, for example, be soil moisture. Soil moisture have a very big impact on the amount of radiation that is reflected back to the satellite sensor. So if we have very dry conditions, a lot of the incoming radiation is reflected back, whereas if it's very moist, more of the incoming radiation is absorbed by the vegetation and less is reflected back to the satellite. This was also seen in these images of the principal component from the first principal component from Lake Mead, where you could see that on the lake it was really dark because all the incoming radiation was absorbed by the water, whereas the dry soils in the desert surrounding the lake were much brighter because it was reflecting the radiation back to space. So ideally, we should try to get images that is taken under similar moisture conditions for both the two different years. The second thing we need to consider when it comes to environmental conditions is something we have already discussed actually. It's about the vegetation phenology. If we would choose an image obtained during the off-growing season and compare it with something occurring during the growing season, in a change detection analysis, it would be considered that, okay, all these forests has been chopped down or all this vegetation has been removed, and instead we have a new land cover with bare soil. And this is, of course, not something that is happening in reality. It's just something that is occurring because the environmental conditions have changed between the two different images. So this phenology is very clear here in this time lapse of photos taken from a tower. You can see during winter time it's not very much, and then during springtime it suddenly gets very quickly, and at the peak of the growing season there is a lot of greenness, and then now soon autumn is arriving and it starts to get yellow, and then suddenly all the leaves will start to fall down. And now we're back at winter conditions without any greenness again. So vegetation phenology is really important to consider when doing a change detection analysis. So finally, we have come to the last part, which needs to be considered with the environmental conditions, which is the atmosphere. The atmosphere should be identical between the two points in time which we are doing our change detection analysis of. So, and there is two different parts which is most important when it comes to atmosphere. And the first one of this is clouds. As you can see here, there is quite a lot of clouds in these images, and say that we would do a change detection analysis of this area. And for one of the years, it was completely clear images without any clouds. And then for the second year, it would look like this. When we then compare the two different images, most likely the first year we would consider that here is perhaps a forest with a lot of vegetation, whereas for the second year, when there is quite low reflectance from this area, it would not be considered a forest. It would be considered something completely different. So when it's actually just that it's clouds in the scene. So this is one thing that is really important to consider. What you see here to the right is an image of the coast of Africa on where there is aerosols blowing out from the Sahara Desert into the Atlantic Ocean. And you can see that this has huge impact on the reflectance of measured by the satellites. So if we would, again, do an analysis of the land cover for two years, one without these aerosols and one with all these aerosols, we would most likely, if there would be no aerosols, we would consider this ocean, whereas in a change in a land cover analysis, this would most likely be considered land because its reflectance is so different to an ocean here. So yeah, so this is something that also needs to be considered when doing a change detection analysis, that the atmospheric condition must be the same. So finally then, to conclude, that when doing a change detection analysis, there are some different environmental parameters that must be considered. The hydrological conditions must be the same. This was illustrated by the soil moisture, which we discussed here. The biosphere needs to be on at the same condition, so the phenological state of the vegetation must be at the same between the two different images. And then finally, as mentioned, just the atmospheric conditions must also be equal between the two images, so that it's not like a cloud or aerosols that cause a detected change rather than an actual land cover change. So thank you very much for listening to this lecture, and have a nice day.